Hey, everybody, we are in the next lesson. 2-4 transformations in the plane. Okay, so let's talk transformations. There are several different types. You've got ones that are rigid. You're going to see this word rigid motion, and that is your basic translation where you shift a figure, reflection where you flip a figure, and a rotation where you turn a figure. You've also got dilation, but that's not a rigid motion. So I seriously doubt we'll see that in here. I don't see that anywhere. Pre-image is your original figure. Image is your new figure. So original, and then what you've done to it, your new. That's your image. All right. Reflection is flipping. Translation is shifting. Rotation is turning. The thing you flip across is called the line of reflection. The thing you turn around is called the center of rotation. Translation vector is how you shift something up, down, left, right. Component form is basically the same thing. I'll have to show you on that one. And then angle of rotation, again, that's how much you're turning a figure. You do need to know that counterclockwise is your default. So if it doesn't say you're going counterclockwise, and y'all, that is left. Okay, here goes. A translation is a function that takes points in the plane and inputs and gives other points, which are outputs. Again, the pre-image is your original, image is your new. Rigid motion is when you don't change the shape, size of the shape. It stays the same shape and same size. Isometry, you might see this word later on because they have a whole unit on transformations. So you might see that word again. Okay. I've already gone over that. All right, let's do it. Example number 1. Okay, you guys, that was all page 95. I'm going to turn the page to page 96. Example number 1. All right, it says identify the type of rigid motion shown in the photo as a reflection, translation, or a rotation. Well, as you can see, it's a reflection because you got water here. And this is the same figure, just kind of flipped upside down. So this is reflection. Oh, that's it? That's all I want? Okay. Moving on. All right, we got to check. All right, checkers is a game of checkers. In the game of checkers, players move their pieces on the diagonal. Identify the type of rigid motion shown as a reflection, translation, or rotation. Well, anytime you just shift something left, right, up, down, that's a translation. Okay, example number 2. All right, at the bottom of page 96. Identify the type of rigid motion shown as reflection, translation, or rotation. Okay, so this looks like a translation because I am taking a figure, maybe the pre-image and the image, and just shifting it over. So that's a translation. All right, for this one, looks like I'm doing some sort of flipping it around and around and around. So the y-axis. Okay, so yeah, it's a reflection. Just flipping it over the y-axis over and over and over again. Woo, 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 woo. Yep. All right. And part C, looks like this is a rotation because I'm turning the figure and making it face a different direction. Although counterclockwise is the default, so woo, going this way. This is rotation. All right, we got to check. On the top of page 97, got to check here. They want the type of rigid motion. And again, the top 3 are translation, reflection, rotation. Dilation is not a rigid motion because it changes the size of it. So you guys, this is, looks like a rotation to me because it goes woo around. So rotation. All right. Moving on. Okay, so I guess we're going to get into a little bit more depth of reflection. All right, so this is what you need to know. There are what I call cheat codes. Any of you guys that are out there, gamers, when you get stuck on some kind of board or some kind of move you need your person to do, you can always go online and look for what's called a cheat code. Same concept here. if you are taking something and reflecting it across the x-axis, you guys need to know the y value changes, because you're going to go right no matter what. You're either going to go right and up if it's your pre-image, and then right and down if it's your image. That means the y value changes signs. So 4, 1 would be for -1, because it's the same distance on the x across the x-axis. All right, y. If you have a pre-image and you reflect it across the y-axis over here, it's the x value that changes, because you went right and then either up or down to get your A and your B originally. Now you're going to go left and go up or down to get your A or B. All right, so across the x-axis, the y changes signs. That's what that little negative right there means. It doesn't mean make it negative. It means change the sign of it. If it is positive, you make it negative. If it was originally negative, you make it positive. Same thing for the reflection across the y-axis. The x changes signs. Again, it doesn't force it to be negative, you guys. What was negative becomes positive. What was positive becomes negative. All right. Notice they haven't done anything about the origin, but there is also a cheat code for the origin where they both change signs. I don't know if that's going to be here or later. So, yeah, keep that in mind. They both change signs. All right, I'm going to turn the page to my workbook. Go to example number 3. All right, it says triangle ABC has coordinates A, blah, B, blah, and C, blah. All right, determine the coordinates of the vertices of the image after reflection across the x-axis. Okay, visual people. This A will be the same distance below the x-axis. The B will be the same distance above the x-axis. And C will be the same distance above the x-axis. But it really just changes the y value signs, everybody. It just changes the y value signs. Okay, so it says predict, graph the triangle before performing the reflection, predict results. Well, that is my prediction. It is going to be the same distance above as below, and vice versa. Okay. All right, here we get down. Here's your cheat code. So across the x-axis changes the y value. So that's going to be 3. Change the y to -2. All right, we're so done. 2. Change this -2 to +2. And 4. Change this -5 to +5. Across the x-axis, the y changes signs. All right, there you go. There is example number 3. And we have a check here. Okay, so wait a second. No, I'm sorry. It's not a check. My bad. I'm just checking, I guess, this problem. I apologize. I saw a check and I'm like, oh, I got a check. Okay. So here's what I was saying. The original A was 2 above. The new A is 2 below. The original B was 2 below the x-axis. The new B, 2 above. The original C is 1, 2, 3, 4, 5 below the x-axis. The new C, C prime, is 5 above. Okay, so part B, reflect in the y-axis, determine the coordinates. Okay, so predict it'll be the same distance left and right. As the original, I can't spell original, figure. All right, so what I mean by that is here's your original figure because it's a regular A, a regular B, a regular C. A is 3 on the right, which means my A prime, 3 on the left. It'll be a boom right there. B is 2 on the right, the new B, B prime, 2 on the left. The original C is 4 on the right, the new C, C prime would be 4 on the left. So what that means is across the y-axis, your X changes signs. Your X changes signs. So it won't be 3, 2. it'll be negative 3, 2. It won't be 2, negative 2. It'll be negative 2, negative 2. It won't be 4, negative 5. It'll be negative 4, negative 5. All right, so we got to check this. All right, so there it is, as you guys can see. Same distance. I don't like that. Makes it look like above, but it's actually the same. All right, so 3 on the right, 3 on the left. 2 on the right, 2 on the left. 4 on the right, 4 on the left. All right, moving on to our check. I'm on page 99. And it says triangle JKL. Do I have a figure? I do not have a figure. Has these coordinates, blah, blah, blah. Determine the coordinates of the vertices of the image after a reflection across the x-axis. What that means is change the y sign. Change the y sign. So 2, positive 8. 6, positive 7. And 4, positive 2. And everybody should have A. All right, there we go. All right, moving on. Okay, talking about translation vectors. Now, you guys, you know that initial point and terminal point we talked about before. We were partitioning a segment and finding, a specific order pair fractionally between two order pairs on a coordinate plane. Translation vector has an initial point and a terminal point. That means where you begin and where you're going in a direction of. It can be northwest, northeast, southwest, southeast, left and up, right and down, that kind of thing. It really is just adding and subtracting, you guys. If you can add and subtract, by goodness, you can do this. It really is just adding and subtracting. If you go right, you add. If you go left, it's subtract. If you go up, it's add. If you go down, it's subtract. Just like, your coordinates, right and up is plus plus type of thing. All right, you know what? Let's just get into it. All right, example number 4. So I'm going to turn the page in my workbook. All right, I'm on page 100. For quadrilateral QRST with vertices, blah, 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 and blah. Find the coordinates of the vertices of the image after a translation along the vector 7, 1. All right, first off, I make sure these are positives. It's a positive 7. It's a positive 1, which means I'm adding 7 to my x values on all 4. The 1 is a positive 1, which means I'm adding 1 to my y values on all 4. That's it. All right, so I'm going to add 7, add y, which means I'm moving right 7 and up 1. So this is going to shift right 7 and up 1. Because I'm going in a positive x value, a positive y value. So right 7 up 1. All right, I'm just simply adding, you guys. Oh, hey, it did it for me. Lovely. Lovely, lovely. So negative 8 plus 7 is negative 1. Boom. Negative 2 plus 1 is negative 1. Boom. Just adding, you guys. Just adding. A 7 to the x values, a 1 to the y values. All right, let's do a check. All right, I'm on page 100 still. And I got a quad. ABCD has vertices, blah, 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 blah. What are the coordinates of the vertices after the image of a translation vector 5, negative 3? All right, first off, the x value is 5. I'm adding 5 to every single x. Negative 3 plus 5, negative 5 plus 5, negative 2 plus 5, and negative 1 plus 5. The y value is a negative 3. That means I'm subtracting 3 from every y value. 1 minus 3, 3 minus 3, 5 minus 3, 3 minus 3. I'm giving you 10 seconds to do that. 9, 8, 7, 6, 5, 4, 3, 2, 1. Boom. There it is. That is your answer. Pause and reflect. Don't have time for that. Let's move on. All right. I am on page 101, the angle of rotation. All right. So first off, I said earlier, the default is counterclockwise. If the ACT does not specify, you guys go left. But clockwise is to the right, just like a clock. counterclockwise is to the left. All right, the angle of rotation is how much you're turning something. For you visual people, here is my original P, and I'm turning it counterclockwise. That's to the left, 90 degrees. And there's my new P. So I'm going counterclockwise, which is to the left, an angle of rotation of 90. And it has a cheat code. All right, 90 to the left. Your original XY becomes negative YX. In other words, they switch places, whoop, and what was the Y changes signs. A 180, a rotation, is a change in X and Y. So your original XY changes signs. Now remember, if your original XY is negative, these mean change the signs to positive. So it doesn't mean force it to be negative. It means change the sign, people. Change the sign. 270 counterclockwise, the cheat code XY goes to Y negative X. In other words, they switch places, whoop, but the X changes signs when it goes in the back. All right, so there it is, visual people. Your original P, 90, 180, 270 degrees. By the way, a 360 is a full turn. 90, 180, 270, 360 back to the original. All right, you need to know those cheat codes, my lovely people. You need to know those cheat codes. All right, example number 5 on the next page, page 102. Okay, so we got a parallelogram, FG, HJ, which is blah, 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 where the coordinates of the vertices of the image after a rotation of 180 about the origin. All right, here's your cheat code. Whatever X is, change the sign. Whatever Y is, change the sign. All right, here it goes. So that means F originally is a 2, 1. My new F is -2, -1. There it is. Original G, 7, 1 becomes a -7, -1. There it is. I feel like I'm singing that song. Whoop, there it is. All right, 6, -3 becomes a -6, +3. -6, +3. Remember, they change signs. And J, which is 1, -3, becomes a -1 and a +3. All right, so we need to check that. I promise you it's correct. Just look at these order pairs right there. All right, and last thing but not least is the check on page 102 before your practice. All right, we got a quad. JKLM has vertices, blah, 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 blah. Determine the coordinates of the vertices after the image of 270. Rotation about the origin. Okay, first off, see how it doesn't specify? 270 doesn't say counterclockwise or clockwise. When it doesn't say, they mean counterclockwise. Here is your cheat code. So the X and the Y switch places. Whoop! And whatever X was, when it goes to the back, it changes signs. All right, so switch their places. 2 goes up front. 1 becomes negative in the back. There it is right there. All right, 3 goes up front. 4 becomes negative in the back. 1 goes up front. 6 becomes negative in the back. 1 goes up front. 3 becomes negative in the back. There it is, everybody. The answer is A. All right, you guys have any questions? Let me know. Have a great day, and I will see you later.